All right, we're going to do another problem about group action. So lights, camera, group action. So since G we know acts on S. Oh yeah, this one is really easy. Uh, Unless I did something wrong, which is possible. We know, uh, what do we know? We know these things. This is just what it means to have a group action. Since H acts on T, we know, by the way, that's not hacts, it's H acts. On T, we know 1T equals T, and H1, H2, T is just H1 of H2T. Now, let U be in U, which we know is equal to the disjoint union, which I will write with the union with the plus inside for, I don't know why. I saw one professor do it that way. I've also seen it, a union with the dot. That's also good. I've also seen it like a bracket, like a union with line with like corners, but I don't really like that. I think the nicest mathematical symbols are the curviest ones, and the worst are the ones that are jagged. But that's just a personal preference. It's nice to have also it's nice to have a mix, but whatever. That has nothing to do with this problem. So big U is this disjoint union. So either U is equal to some element S, which is an S, or U is equal to some element T, which is in big T. If U, now we're going to do every case. Then 1, which I claim is which is just the one element of this action. This is just 1S, which is S. And if we have G1, H1, and G2, H2 acting on S, then this is just, if you look at what this composition is, this will just be G1, G2, H1, H2, S, which is equal to G1, G2, S, which we know is equal to G1, G2S, which is equal to G1, H1, acting on G2, H2S. And yeah, that last one is because G2, H2, that S is obviously going to give us G2S, which is going to be in S. Oof. Oh, now wait a minute. What if H2S could, okay, so S is in S, G2S, could G2S be in T? No, it can't, because G acts on S. So G sends elements of S to S. So G2S is an S, and so G1 of so this all holds. So this thing is going to give us something in S, and so when we act on it by this thing, you'll just use the G1 there, and so it will give us this, and so there we go. Okay. I was worried there that I would have messed something up. So, anyways, let's consider the other case. It's pretty much the exact same thing. If we're in T, then 1 comma 1 is just 1. And of course here, the 1 is coming from here, because that's the T entry, the T index. And if we let G1, H1, and G2, H2 act on T, then this is just going to be the same as letting the product act on T, which we keep the H's, and then we use the fact that H acts on T to do that. Then we just do this again. And of course, this uses that same argument that tripped me up in the beginning. So anyways, hence, G cross H acts on U as above. And there we go. This completes our proof.